Mario's 10 questions about the periodic table. Mario's 10 questions about the periodic table. Okay. The modern periodic table is arranged by increasing atomic number. Good evening, Mars 42 from far north Queensland. Not atomic mass, thanks to Henry Moseley's work in 1913. The periodic table. Well, I think it's correct in terms of atomic number. The only areas of doubt here are Henry Moseley, who I think there was a Moseley that was involved in the Communist or Nazi Party in Britain during World War II and 1913. So I'm going to go with true, but there is some areas for potential errors here. But yes, I'm with T for true on this one. It's definitely atomic number. Hydrogen has one atom, I think, or H2. Hydrogen is the first one, isn't it? I don't know what the next number on the periodic table is. Hydrogen. I think oxygen is at 8. I'm not sure. True. Moz says true as well, so we'll go with T for true. And let's see if we can get through without confusing grok tonight. Yes. Periodic table. That's correct. Dmitry Mendelev's 1869 table was ordered by atomic mass, with some swaps for properties. Henry Moseley's X-ray spectrophy 1913 showed elements should be ordered by atomic number of protons, resolving inconsistencies and confirming the modern structure. Well, good old Henry Moseley. Thank you, Henry. We'll move on to the next question. Question 2. Second is helium. Yes. Hydrogen, helium. I think there's a mnemonic for remembering the periodic table. Unobtainium. There are currently 118 confirmed elements on the periodic table, with the most recent additions nihonium, moscovium, tenesium, and organesium, officially named in 2016. Lithium. Oh, Moz is a yes. Hydrogen, helium, lithium. Are they the noble gases? What are the noble gases? Yeah, helium. Atomic number 2. Lithium. Ooh. All right. Well, we've got a periodic table. The super heavies are waiting. All right, they would be super heavy. So, yes, most recent, nionium, moscovium, technetium, and organicion. Okay. Um, True, but not sure. Yes. Where's that potential? Def true. Um, yes, I couldn't argue with that logic, Moz. 2016 was a good year, though. It was a good year, 2016. Correct. As of January 2026, there are exactly 118 confirmed elements. The four super heavy elements, NH, MC, TS, and OG, were discovered between 2003 and 2010, officially recognised by the IUPAC in 2015, named on 28th November 2016. No new elements have been conserved since. How does one find a new element? Obviously, atomic number. Yeah, have to find them in order, I guess. Right. Yeah, because have they got every? I suppose they've got every number. We're about to find out, I think. Sorry, that number's taken. I think they'd be able to predict. The periodic table was first published in its modern form by Dmitry Mendeleev in 1869, and he left gaps for undiscovered elements, correctly predicting their properties. Well, I don't think that's true, because Mendeleev did his one on atomic mass as per question 1. So I'm calling false on this one. Its modern form was not till 1913 when Moseley did it on atomic number. But Moz says true, so we'll go with true. Okay, I'm just putting my point of view there. Please be a fart. Oh, yes. Try not to try not to get into the speaker. Oh, that's come back at question 2. We've done question 3. Oh, what have I done? Did I push the wrong button? Focus. Focus. And we're going T for true on that one. We'll see what happens. It's coming round. It's a heartache. Here we go. I can feel it. Correct. Mendeleev published his first table in the 6th of March, 1869. He deliberately left gaps for Eka aluminum, gallium, discovered in 1875, Eka silicon, germanium, discovered in 1886, and predicted their properties with remarkable accuracy, including atomic weight, density, and reactivity. This was one of the strongest proofs of his system. Okay. All right, 3 from 3 as we go now, carefully. N for next. Okay. Question 4. 3 from 3 on the periodic table. Okay, and what do we have? What do we have here? What's happening on the periodic? The lanthanides and actinides were placed in the main body of the periodic table between groups 2 and 3. What the hell are you talking about? I've got no idea. I understand the periodic table, but I'm not familiar with the grouping. Yeah. But yeah, I could neither confirm nor deny that. If my life depended on it, I would say true and hope for the best. But the lanthanides and the actinides, not sure. False. Moz says false. Okay. 'Tis done. 'Tis done. Do you know what you're talking about, Moz? True or false? We'll see. We're orbiting the F block. All right. No. Must be true. It's correct. The lanthanides, elements 58 to 71, and the actinides, 90 to 103, are the F block elements. They are not placed in the main body, which would make the table extremely wide. Instead, they are usually shown as separate rows below the main table, with a placeholder between groups 2 and 3. Groups 3B in older numbering. This convention keeps the table compact and readable. Well, there you go. Sounds right. You're a bloody genius, Moz. Yes. Oh, well. Who knew? Yeah. Obviously, there's more to the periodic table than meets the eye. N for next. Okay. I see they're going to ban X in Australia for showing your prime minister in a bikini. Group 18, the noble gases, are called inert gases because they have completely filled electron shells and do not form compounds under normal conditions. Certainly there are the noble gases, and they're also inert. Yeah, I'm going true. I'm just loose though. I don't know about the completely filled electron shells, but that would explain them not forming compounds, I guess, because they got nothing spare. Like there's no helium oxide. True and true about X. PM is a wimp. Yes, but does he wear a bikini? T for true. Mr. Albanese. What? This is going a bit weird. Hang on. We just that's right. Oh, well, there we go. Group 18 elements: helium, 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 neon, argon, krypton, xenon, and what Rn is. Anyway, have full valence shells, octet rule satisfied, making them extremely stable and unreactive. Hence the old name, inert gases. They were thought completely unreactive until 1962, when Neil Bartlett synthesized the first compound, XPTF6. Now we know xenon, krypton, and radon form compounds, but under normal conditions, room temperature and pressure, they still do not react. The name noble gases is preferred today. 5 from 5, the noble gases. Next. For next, not for noble gases. Radon, okay. Oh, right. Good. Albuquerque, yeah. Question 6. The element with the highest electronegativity on the periodic table is fluorine, which has a value of 3.98 on the Pauling scale. 3.98. That seems a bit high. He says knowing absolutely nothing about the Pauling scale. That's appalling. The element with the highest electronegativity on the periodic table, fluorine. Fluorine gets a pretty bad rap, but it's 3.98 on the Pauling scale. I must try and get that into conversation next time someone's talking about fluorine or fluoride. I'd say, but yes, you must remember, of course, that it is 3.98 on the Pauling scale. And they say, oh, what's the Pauling scale? Well, that's appalling. You don't know that. Dear me. The Pauling scale. Fluorine or fluoride. Put it in your water. Aren't they putting it in your bread? What's the one they're going to put in the bread? Fluoride. No. There's something they're going to put in the bread. True. Moz says true for that. T for true. All right. Wow, we're 5 from 5, so we're doing pretty good. And we've got one false in there. So we've picked the false one in the first half of the quiz. We move on now. True, correct. Fluorine holds the record for the highest electronegativity at 3.98 on the Pauling scale, the most widely used. Cesium, 0.79, and francium, approximately 0.7, are the least electronegative. Electronegativity increases across a period and decreases down a group. Oh. So there's periods and groups of the what? What the hell? Okay. In terms of the periodic scale, briefly explain groups and periods. Okay, what's going on here? Move the sidebar. So this is here. So what's going on? Groups are the vertical columns, top to bottom. Elements in the same group have the same number of valence outer shell electrons, so they tend to have similar chemical properties. Group 1 alkali metals are all very reactive. Periods are the horizontal, the rows. Elements in the same period have the same number of electron shells, energy levels. As you move across a period, the number of protons increases and properties change in a regular way. Metals, metalloids, non-metals. Oh, there you go. I didn't know that. Right. Okay. Well, that's yeah, okay. Periods and groups. There you go. Yes. Oh, well done, Moz. Okay, let's go for the next. I should have known that. Oh, this is all part of your metallurgy studies, I guess. Is it? Elements in the same group, vertical columns, have the same number of valence electrons and similar chemical properties. All right. Yes. Oh, well. There we go. There we go. I think we can say yes to that one. I sort of predicted that. Okay. It was a bit of an obvious question, I guess. All right. I think that'd be true. Yeast. What? What's the yeast comment about? Yes. I'm not following that yeast comment. Where did that come from? Was it something I said? That's correct. Elements in the same group share the same number of valence electrons, outer shell electrons. That's why they have similar chemical behavior. For group 1, alkali metals all have one valence electron and react vigorously with water. Group 17, halogens, have 7 and form ions easily. Oh, no. Oh, okay. No, there's a mineral or something. That they propose to put in bread. No, there's something like fluoride that they've been proposing to put in bread, or they put in bread in some countries to inoculate the population against, for something, can't think. Right, question 7. Right, next. Yeah. No, they've talked about it. I've heard people talk about it. Iodine. Oh, right. Folic acid. That's the one. It's folic acid. Yeah. Mandatory from 2023 in New Zealand for bread making flour. Folic acid, vitamin B. Yeah, they put folic acid in the bread in New Zealand. Except organic bread. Okay. The periodic table is divided into four blocks: S block, P block, D block, and F block, based on the subshell being filled in the atom's ground state. Well, they have talked about the blocks. I'm not sure. Sorry, sourdough, not Bambi. They use vinegar to make fake sourdough bread. Oh, okay. All right. Yes. No. It's something. It is. Yeah. The big reasons for folic acid in bread are. I'll put it up here. Timing. The neutral tube closes very early in pregnancy, so supplements only help it taken before conception and in early pregnancy. Reduces neural tube defects like spina bifida and anencephaly. Coverage. Lots of pregnancies are unplanned and supplement use isn't consistent. Fortifying a staple food helps more people get protective levels. Help groups with higher NTD. All right. Evidence. Countries that fortified flour like Australia. Okay, it's also in Australia as well, apparently. Folic acid. Okay, yeah. Sourdough, not Bambi. All right. Right, so what have we got? Question 8. Is this true? I think true. Yeah. Question 8, I believe that to be true. There is definitely blocks. And whether that's, yes, teeth true. Yeah, folic acid is the one I was thinking of, and it's, yeah, to help prevent spina bifida in children. But it looks like it's also invalid. Correct. The 4 blocks respond to subshells being filled in the valence shell. S block, P block, D block, and F block. All right. So there's more to this periodic table than meets the eye. Okay. I'm sure they probably said that once at school, but I never took much notice of it. Intriguing. They've put a lot of thought into it, haven't they? Right. Technetium, atomic number 43, and promethium, atomic number 61, are the only 2 elements in the periodic table with no stable isotopes. Well, is this true or false? Got no idea. Promethium and technetium. Promethium and technetium. What do you weigh? When I went to school, we had a block, B block, C block, and D block, which made up the buildings. Yeah, well, we had H block as well, which was shaped like an H. It had 2. It was a 2-story. They were actually called Nelson blocks because they were made in Nelson. They were designed in Nelson, but it was shaped like an H, and it was H block. Yes. But we had A block was the administration block, B block, C block, D, E, F, G, H, I think we even went up to J. I think at one stage I was in 4J1, which was a prefab in J block. Yeah. I was thinking that too. H block. I think H block. Yeah, I think it's true. Yeah. J. I don't know if they had K and L. No, I think J might have been the maximum. Oh, it's true. All elements up to bismuth 83 have at least one stable isotope, except technetium 43 and promethium 61, which only radioactive isotopes. Tc is the lightest element with no stable form and is completely synthetic on Earth. Pm is also entirely radioactive. No other elements in the table share the distinction. 9 out of 9. And we go to question 10. We could be looking at a perfect score here. If only we can get question 10. Okay. We wait. We wait. The folic acid. Our PM is radioactive. Are there any isotopes? Right. What happened there? N. We want the next one. Does he form isotopes? Who was the last Prime Minister of Australia that you had any time or respect for? You know, going backwards. Here's the final question. The International Union of Pure and Applied Chemistry is the organisation responsible for approving new element names and symbols. The IUPAC. No, I'd say that is true, but yeah, I would go true with that, but it could be wrong. It could be the international unit, the international organisation for approving new element names and symbols. But I wouldn't know. Malcolm Fraser. Okay, yeah. Right. Malcolm. Yeah, he's still around too, isn't he? All right. Malcolm Fraser. Oh. Yeah. I can remember him. Yeah. Explain IPAC's naming process. True. We're going T for true. So we're getting into. Oh, good Lord. Okay. Here we go. Well, T for true. And true for T. Correct. IPAC is the global IUPAC. UPAC is the global authority for chemistry nomenclature, including the official naming and symbol approval for new elements. After discovery and verification, the discoverer's proposed names but IUPAC reviews, approves and announces them, e.g. the 2016 naming of elements 113, 15, 17 and 18. Oh, okay, but 14 must have already been known. Right, well there we go. 10 out of 10. A flawless performance. You conquered Moseley's atomic number revolution, the 118 confirmed elements, Mendelev's prophetic gaps, F-block placement, noble gas stability, fluorine's electronegativity, crown group valence similarity, the 4 blocks, TC's PM's invisibility, and IUPAC's naming power. No gaps, no errors. Bloody marvellous. This has been Maurieo's 10 questions about the periodic table.